Good afternoon again. Thanks, Nico, for the introduction. I will try not to. No, it should be better. I will try indeed not to talk as a politician or something like that, but to be technical because actually I'm still a technician and scientist at heart. I'm here today, so I represent DJ Connect, which is part of the European Commission, the Director General in charge of networks, contents on big infrastructures. And in particular, I'm representing the high performance computing unit that is also in charge of applications for HPC. And I will talk today about destination Earth, which is the main application that we are developing. What is a destination Earth? It is a digital replica of the Earth, or should be, but is a digital twin of the Earth. And here, I mean, you can read the slides, but I'm used to define digital twins by their capacity to answer three questions. The first one is, what now? This is monitoring. This is something that all of you know very well because Earth observation is one of the main entry points that we have for monitoring the Earth and taking the pulse of the planet, as was the slogan of some agency a few years ago. It's still valid and it's working pretty well. And actually, the vibrant community that you are forming is a clear sign of that. Then you can go to what then. And what then, it's mean prediction. This is, for instance, what we are used to do with weather forecast, with also climate simulations now. But it could be actually what then for every impact sector or sectors we are working in. And this is something that is mature in certain domains, maybe not in all the domains. Predictive Earth observation maybe is around the corner. And that's a second key feature of digital twins. The last one, maybe the more prospective, but also the more interesting, is to be able to answer to what if question. That is to be able to play different scenarios and to take decisions based on these various simulations, these various output of the digital twins. So this is a big picture. Now I will show you how we build, or how we try to build this digital replica of the planet. So first, at the core, there will be, there is actually already, there are two core digital twins. One for climate, to be able to answer questions about food sustainability maybe in 20 years from now, because if some place has been transformed in desert, you will have issue to grow anything on it. And also, much shorter term, weather-induced extreme digital twins, that is weather forecast at very high resolution for the next days. So this is a boring slide of my talk. Sorry for that. But it's good to present also who is doing what. And indeed, as a commission, we are funding that. This is a big program over several years, from 2021 to 2028. €500 million, so quite huge investment. Beyond that, beyond the supervision, we are actually delegating the implementation to three entities, trusted entities, which are actually well known also. A CMWF, the Medium Weather Forecast Agency for Europe, in charge of the core digital twins, and so the digital twin engine. EUMETSAT, so the European meteorological satellites. I'm not sure to have all the letters, the acronyms, but responsible for Meteosat third generation now, but also providing the data to the Met offices. And they are responsible from the data lake, you see, with their data expertise. And finally, the European Space Agency, ESA, for developing the platform on co-design. All of them are working together, delegating again to companies, research institutes all over Europe to build this thing. Where are we now? So first it started really in 2022, with the first phase finished in 2024 on the delivery, on the release, the public release, on public opening of a first prototype. Now we're in phase 2, where we are enhancing and fixing what needed to be in the prototype, with a milestone next year, mid-2026. And then there will be phase 3 on subsequent thing. But the idea is to go to operations, that is to have something like Copernicus, maybe we think Copernicus, because we are discussing a lot with our colleagues, of course, that will be operational and can be deliver added value to the users, to all European and beyond people. So here I have a question. Who knew that destination Earth first exist and was available? Not bad. But have you learned that today from me or no? Okay. Who? So it's not the majority, so. And who has ever tried destination Earth? Okay, so. Thank you. Thank you very much. You are saving at least the my day. But you see, so I mean, it has been open to everyone from 1 year and a half. And indeed, not many people know it exists. Not many people know they can onboard on it and they can use it. And actually, that's something that I mean, the reason of my presence here today is to explain what it is, and hoping that you will go to Destination Earth and you will register and try it, because I think there is a huge potential, especially for researchers right now. So what is it? As I said, climate change adaptation on digital twin for that. It's a kind of multiple decade simulation up to 2050 at very high resolution, 9 to 10 kilometers. Okay, maybe, sorry, can better like this. So 9 kilometers. And so providing, so if you compare to Cordex or CEMIPS, they go longer in time, but the resolution is much coarser. The other digital twins, weather-induced, which is kind of numerical weather forecast, NYP. Here you have every day 4 days of prediction at 2 to 4 kilometers resolution, which is also much better than, I mean, the IFS, for instance. The standard weather forecast of the CNWF is around 10 kilometers. We can also trigger at 500 meters regionally for 2 days. On this, so now I will explain a bit of this. Climate DT, this is actually standard models of the community, IFS, NEMO, FESOM, ICON, that are run by the lead contractor, CSC, on supercomputers, and that are able to provide indeed this kind of very high resolution. Sorry. And here you can see the difference of resolution with, I guess it's Cordex on the upper side of the image. So indeed, big increase of resolution. And of course, the idea would be to be able to plug in impact sectors on it. What we have now, and what they have produced, so there is already this data, and they are reproducing the refined version, is historical data back to 90, so for validation, and projections up to 2050. All the 3 models, so you can have also kind of mini ensemble. For this, we are a bit rich guys around the block, because we are using supercomputers in Europe, namely LUMI, Mare Nostrum in Barcelona, also in Bologna, the Leonardo. So we have this huge capacity, and this was needed. So it was not something that anyone could have produced. But so this is a huge resource, because the data then are open. The kind of insight you can gain with climate DT, for instance, I mean, just by the resolution, is something that is able, for instance, to really have something much more fine-grained, and to have something that is really, so you can really develop applications which are really important locally. Here, for instance, on island, I guess it's Canarias, you can maybe name the island, but you have something that first is much more resoluted, but also match the observation. So here we see that there is a good validation. Here compared, for instance, with the reference data set ERA5, which is a reanalysis data set of weather forecast. No, so sorry, yes, of weather forecast plus assimilation of observations, which is the basis which all the AI models of Google, of OCNWF are built on. Here also you see that with this simulation, we are able also to reach a fine better resolution. And one interesting application of that is that you can use this climate simulation as a forcing to be able to replay some events, and especially extreme weather events. So here, for instance, in the middle, you have a current, I mean, nowadays, the current event, it was a flooding in September 2024. So huge precipitation over Europe, consecutively some flooding. And you see that in 2040, if you had the same kind of precipitation, but with this kind of initial conditions, it could be worse. So it means that also all the cascaded events would be worse. Also. So this is the kind of thing that you can prepare yourself for the climate of a few years ahead. This, of course, it's not, I mean, not only weather forecast or climate forecast, but what is the impact? So it could be for where do you need to have your windmill energy factory or solar panels or this kind of things. On the other hand, we have the weather forecast with extreme DT. And here, it's 4 days ahead at 4.4 resolution. Again, the same kind of models that the Met offices are running, IFS NEMO. And for the regional side, so over Europe, or the region that you decide to trigger your event on, 500 meters. What they've done so far, that is, they triggered many times the high resolution to test that on extreme weather. Because indeed, this is one of the limitations of the current weather forecast, is that due to the resolution, you're not able to have this huge peak of precipitations, of wind that can happen. But here, at least they were able to match that and to be also, depending on the topography, to be able to see what will happen on the ground. One example here of compared resolutions. So on the bottom, you have the prediction various model. Here, the most well-resoluted one, the triggered one. Here, the observations around the world. Here again, so various models here compared to the observations. One thing to understand also because, like yourself, I'm coming from AI. On the one easy answer to say, oh, but you just have to do downscaling, super resolution, and you will have the results. Why you're bothering to run all this model? The thing is that with numerical models and weather forecast, actually it's much better than super resolution because actually the prediction you are doing based on the physical equations are actually influencing also the, let's say, the results that you would have at a lower resolution. So it's not the same as just super resolution. It's really having much more detail plus having a better prediction for all the area. Okay, and that's why this part yet is still not AI, but really based on physics grounding. Now we are moving to an AI Earth system. So first, indeed, a CMWF, for instance, has released, and was the world premiere, has released the IFS and then the Ensemble AIFS last year, which is an AI-powered forecast system, global. What we are building in Destiny is to have all the, so weather forecast system means that you are modeling the atmospheric component of the Earth system. Now we have all the other components, the oceans with the waves, the cryosphere, the land, many things. On this, now they are developing the AI modeling of this component to be coupled with the weather forecast. And in the end, eventually, phase 3, maybe after, you will have also for the impact sectors, small digital twins corresponding that can be really specified, taking into input the core digital twins output, and then specified to ad hoc applications. An example, for instance, of this modeling by AI of the cryosphere, the sea ice. Other kinds of AI that you have also, we are at REO, so I did a few slides and I thanks Pega for reminding me that we have chatbots also a bit everywhere. There are many things for which AI could be used, and that is planned actually in Destination Earth. Climate simulator, understanding the uncertainty of the model and trying to couple also various components into one uncertainty. AI forecast in a box, which is developed and that is now actually uptaken also by the World Meteorological Organization, by various Met offices. So basically, you can develop your local AI model and transfer it on another region and run it on a single computer, not having the need for the supercomputer as before. And this is a huge improvement because it means that everyone can run a model, a regional model, maybe, even if you don't have the power to have the HPC infrastructure or the scientists and so on. And of course, there will be, and there are already chatbots everywhere to try to explain what are the outputs of digital twins, but also to understand what could be the reasoning, to understand what kind of data is available, and so on. So now I will try to fasten on to move to use cases because this is maybe where you can be actors and players in this system. We had actually lots of use cases which are already tested in phase 1. You see them here. So it can go from, industrial sector, agriculture, very energy, but also, more societal things like disaster risk management. We discussed that a lot. Now we are exploring more use cases, and I will show examples of them. But what you have to know is that actually you have an entry point, which is very easy. You have the URL here. This is the way where you can explore Destination Earth. And if you go there, you register. You will see it's easy. Then you have various kind of services which are already available. The first one, just to check what kind of data you have. For instance, I know that many people here are coming from Earth observation. So what ESA has developed is Highway. Highway is a kind of applications giving you access to all the Earth observation catalog from ESA. So you have all the kind of satellites they have, the Sentinels, even the Earth Explorers, and you can access this data. So maybe you are using that. Now you can use that with the Destiny data, the digital twin data, and all that in a single place. Bottom line, you have all the applications and services that help you to build AI pipelines or your own application. You will find something you're very used to. You can have your little Jupyter notebook, import your code using some tutorials. So something very easy. There are many competitors, many services. You will find actually the one that fits your habits, that suits you. I discussed with a colleague at GRC who is using Insula, for instance, for developing a disaster risk assessment tool. Okay. And then maybe, this really for you, I guess, researchers, this could be something very useful. So I urge you to test it. Now, if you just want to see what is possible, or maybe you won't be a scientist for long and will come to policy making or to user-oriented stuff, but a real user, not developer, then you have actually already some kind of digital twins or applications that help you to understand what is possible. Since we're in Copenhagen, I can talk about City Nexus, which is a kind of urban planning digital twin, where you have traffic and mobility data coupled with pollution, CO2, NO2, on the urban planning. And you can play with urban planning there. So this you can, oh yeah, I want to have a low emission zone here. I want to have pedestrian streets there. I plan what will happen then. What kind of, and you can run different kind of scenarios and choose the one that is corresponding to the policy that you want to implement. moving on disaster risk, because we talked a lot about that with Julia already. But indeed, you have many use cases which are now so either not AI, and also machine learning demonstrators, also on wildfires, actually. So again, please try it. Please have a look, Christian and Julia, because I think that could be interesting for you. But everything here, maybe the one also on the top of floods, which is really an example of implementation with a national service that is, it's with the Italian service that is measuring the gauge of rivers all around Italy, and how they can use Destiny data to have a better predictions of the potential floods. On here, maybe an important slide, I mean, from a theoretical point of view, in the sense that we are used, I mean, to a certain paradigm. That is, with Earth observation, we went from not having data and just having physical models and so on, but we went to have this data, Earth observation from space mostly, that help us to understand what is happening. With digital twins, there's a kind of paradigm shift, because in the end, we won't have this single way path, but we have something that is more cyclic. That is, a user also will run, for instance, you will implement factories somewhere, so there will be an effect on the carbon. So there will be this kind of cyclic things, and this is exactly what the digital twin should be able to do. Just to finish, to conclude, destinationers.eu, that is the generic website to give the information. Your entry point, platform.destiny.eu. Really easy to you register, and most of you should be, I mean, you're European based, so you should be able to register. It's now the policy access is quite open to everyone. Some applications already to test. We have also the data lake, and here, this is giving you something that is even more, maybe more interesting. That is access to many data, of course, in an harmonized way, but also by submitting a request for upgraded access, you can also have compute power. And here, the data lake is that you have data, all the data that is coming fast, but you have also compute power that is close by the data. So you can really run your models close to the data with enough GPUs, and it's going fast. I was also interacting with a colleague at GRC who run the Cyclada model, which is something for risk assessment of cyclones, the impact. And indeed, it was great because it was kind of moving a step further, faster for him. So this also, I mean, just tell in the request that you see this presentation at a RIPS REO by DJ Connect, and you will get the regulated access. You have here the QR code if you want to take a picture. Of course, all these things, it can be a bit frightening because there is a lot of things you don't know where to start. Good news, there is also some capacity building that is planned and that is already available. We have the Learning Hub of Destiny, where you have tutorials, you have examples, you can have a notebook to guide you to start the things, you have videos, many ways of learning how to use the platform. So again, everything should be planned. So I put many, so this is my last slide, almost last. Many things here that summarize what I've said, but the main message is, come on, you're welcome, okay? This is a great resource for you, I think. I mean, if I were still a researcher, I guess that would be a good opportunity here to do new things, but also because we need you. We need you to co-design Destiny and to receive feedback from the research community. And I don't know who is better placed than people from research, innovation, startups, emerging companies to test this kind of new functionalities and to help us to build this infrastructure that in the end should be helpful for everyone in Europe and globally. Thank you for your attention. I leave you with this animation of the Destiny compared to previous models, showing a bit of how resolution can be helpful to model the atmosphere. Thank you.